Welcome to Tomorrow Unveiled, the show that gives you a shortcut to the future by diving deep into the most complex technical documents and boiling down the breakthroughs that actually matter. We are seeing a massive, a really seismic shift in the artificial intelligence landscape.
Yeah.
I would argue it's the biggest one since, generative models first burst onto the scene a few years ago. You probably noticed the conversation has changed. It's not really about whether an AI can write a better poem anymore. It's about whether it can reliably do your job. And the launch of Gemini 3 Pro, it's not just another incremental step. It feels like a strategic pivot, a real push toward making AI a reliable, autonomous worker.
Yeah.
We're officially moving past that era where AI was just a smart chatbot.
Yeah.
We're now entering the age of the what we're calling the reliable doer.
Exactly. The whole focus has shifted. It's moved from, just retrieving information or generating text to agency. And by agency, we mean the ability for the AI to reliably plan, to execute, and to manage these really complex multi-step tasks all on its own without a human constantly holding its hand. This is what the industry has been calling the last mile problem for enterprise AI. And all the sources we've reviewed, they really suggest Gemini 3 is finally tackling it head on.
And that's our mission for this deep dive into Tomorrow Unveiled. Our dedicated research team has compiled a huge stack of sources for us. We're talking comprehensive technical reports that detail the architecture of Gemini 3 Pro, and they've combined that with independent data that places it right up against its key competitors. So we're looking at direct comparisons to, say, the announced capabilities from rivals like GPT 5.1 and the Claude 3 and 4.5 series.
Yeah, and our goal here isn't just to, read you the press release. We're here to distill the core, the corroborated breakthroughs. We want to explain precisely how this new era of AI agency impacts technical workflows for developers, for enterprise users, and maybe most importantly, to show you what this new level of reliability actually means for your daily experience when you use these tools.
Because the complexity of engineering these truly agentic capabilities is just immense. But the strategic implication for you is actually quite simple. If the AI can reliably handle these long-running multi-step workflows, things like refactoring an entire code base or synthesizing a complex legal document, well, that changes the economics and the capabilities of almost every single industry.
We're going to unpack this across three key areas that really explain this massive leap. First, the radical architectural changes that make this reliability even possible. We'll get into the sparse mixture of experts approach. Second, we'll translate what the quantifiable dominance in these new, really demanding reasoning benchmarks actually means. And then finally, we'll explore the revolutionary ecosystem features, things like generative UI and anti-gravity, that are completely transforming how we interact with the machine. We're moving from commands to actual delegation.
Okay, let's start under the hood, because the power of Gemini 3 isn't just about adding more layers. It's about fundamentally rethinking the entire engine. And the core change, which is corroborated by all the technical reports our research team compiled, is this full high-scale embrace of the sparse mixture of experts architecture, or MOE.
This is so critical, and it's really where we need to spend some time because it defines everything else, the speed, the cost, the intelligence. So think of a traditional or a dense large language model as a single massive brain. Every single parameter, every one of the trillions of weights and biases is activated and contributes to every single calculation.
Every single time.
Every single time. Whether you ask it to write a simple text message or solve a complex calculus problem, the entire model lights up.
And that's what leads to those incredible computational costs, the slow speeds, and you hit a point of diminishing returns once you get to a certain scale.
Precisely. Now, MOE, on the other hand, is like creating this massive, sophisticated brain trust. It's composed of dozens, maybe even hundreds, of highly specialized subnetworks. The technical literature calls them experts. And the core innovation of the sparse MO architecture is that the model might have trillions of parameters in total, so theoretically immense capacity. But for any single task, any single input token, a highly efficient routing mechanism selects and activates only a small, specific fraction of those experts.
Only a few.
Usually just 4 or 8 of them.
So you're not lighting up the whole trillion parameter network. You're just efficiently calling on, the 5 or 6 best specialists for that exact problem, whether that problem is generating Python code or translating some niche dialect.
That is the perfect analogy. And this structural choice is brilliant because it solves the fundamental scaling paradox in AI development. First, it lets you have vast parameter scaling, a much larger overall capacity than any dense model could ever achieve affordably. But second, and this is the critical part, it keeps the computational cost per token, and therefore the latency and the inference cost manageable and low.
You decouple the two things.
You completely decouple the model's total capacity from the cost of running a single query, which means you get maximum intelligence without these astronomical running costs.
That makes a ton of sense. So they can build this gargantuan model without bankrupting themselves, or, more importantly for us, without bankrupting the end user on every single interaction. And the research we saw suggests this architecture is what enables that high-end specialized intelligence they're calling the deep think capability, right?
Absolutely. DeepThink is basically the model leveraging this MoE architecture to its fullest, most specialized potential. When you give Gemini 3 a really complex task like an intricate logic puzzle, a specialized math problem, or a tricky abstract coding challenge, the dynamic routing mechanism doesn't waste time. It intelligently directs that task to the 2 or 3 experts that were specifically trained in those precise domains.
So if I ask for a complex piece of code, the router immediately hands that off to the Python syntax expert and maybe the algorithmic reasoning expert, and it completely bypasses the historical poetry expert.
Yes, it allocates compute resources dynamically. It makes sure that the hard tokens, the ones that need that intense specialized reasoning, get routed efficiently to the most appropriate, dedicated parts of the network. Older, dense models, even really large ones, they just couldn't do this with the same surgical precision. They had to rely on a generalized, slow effort across the whole monolithic structure.
Right.
This dynamic allocation is key to the performance scores we're going to talk about in a bit.
And speaking of the architecture, the sources our team found highlighted a really fascinating infrastructure detail. The entire model was trained exclusively on custom Google Tensor Processing Units, or TPUs. I want to push back on this a little because it sounds like a very closed system. Does that kind of vertical integration create an unfair advantage, or maybe even introduce some form of testing bias?
That's a highly perceptive point, and you're right to ask. Training a sparse MoE model, especially at the scale of trillions of parameters, involves this massive communication overhead between all those separate experts. Data has to be passed rapidly and repeatedly between them. So Google's vertical integration building their own chips, the TPUs, which are specifically designed for the high bandwidth interconnects that MoE routing needs, it absolutely gives them a competitive advantage.
A huge one, I'd imagine.
It's a massive barrier to entry for competitors. Now, it doesn't necessarily introduce testing bias into the benchmarks themselves. Those are standardized tests. But they are operating in this closed loop of hardware and software optimization that is very, very difficult for rivals who are relying on commodity GPU clusters to replicate efficiently. The efficiency gain isn't just a little better, it's structurally guaranteed by their integrated hardware design. That is a huge strategic asset.
Okay, let's move from the internal engine to its senses. Multimodality. We hear this word all the time now, but Gemini 3 is touting native multimodality. I want a technical breakdown of why native is so different from the stitching together approach we saw in earlier models.
This is a foundational distinction in AI design, and it speaks directly to the quality of the reasoning. Many previous multimodal systems essentially worked in 2 stages. They'd have one encoder, maybe a dedicated vision model, to turn an image or a video frame into a text description.
A translation.
A translation, exactly. And then a separate large language model, the LLM, would process that description. They were stitched together using these adapter layers, which created a kind of broken telephone effect.
So the older systems weren't really seeing, they were just reading a transcript of what a separate visual model told them it saw.
Exactly. Whereas Gemini 3 was trained natively from the very beginning. It was fed a mixed data set of text, code, images, audio, and video all at the same time. And crucially, it processes all of them within a single unified transformer stack. It doesn't need to translate an image into text before it can reason about it. It understands the visual and auditory data directly, connecting pixels, sounds, and text as foundational concepts.
That sounds like a profound difference in comprehension, especially for dynamic or complex inputs where timing and context are everything. What are the real-world results that validate this integrated thinking? Can we move beyond just static images?
Well, the most compelling evidence that was cited in the technical analyses comes from benchmarks related to dynamic content. Our research noted the high score of 87.6% on the video MMMU benchmark. And this test specifically evaluates the model's ability to analyze temporal and spatial data at the same time.
So understanding what is happening, where it's happening, and how it's changing over time, all inside a video stream.
Precisely.
That's incredible. Give us a practical example of what that 87.6% score lets a user do that just wasn't possible before.
It means the model can now analyze dynamic content with really human-level granularity. Imagine you upload a video of a technical process, say, calibrating a complex machine or performing a specific medical procedure. The model can watch the video, synthesize the audio instructions from the speaker, cross-reference the text that's shown on the screen, and then critique the operator's form or even identify a missed step. Or for an enterprise scenario, think about taking a video lecture on a new programming concept. The model can synthesize the content of the slides, the audio track of the instructor, and the code demonstrations on screen, and then generate interactive coding exercises or flashcards based on that integrated understanding. This genuine cross-modal reasoning is what those patchwork systems just really struggle to achieve with any kind of high fidelity.
And for developers who are constantly trying to balance performance against cost, our team highlighted a granular feature that really speaks to the engineering focus here, the media resolution parameter. That suggests they're giving users control over this expensive process.
Yes, and this is a beautiful nod to efficiency and enterprise economics. Not every visual task needs maximum fidelity, and maximum fidelity, as you guessed, it costs more tokens and takes more time. So the media resolution parameter lets developers actively tune the input image or video frame fidelity between low, medium, and high. You choose. If you just need a general description, say, identifying that a car is red and is moving, low medium is perfectly fine. You optimize for cost and latency. But if you're using the AI to read the fine print in a scanned legal document, so doing high-fidelity OCR, you absolutely set it to high. This ensures the model allocates the maximum precise resources needed to capture those fine details and minimizes the chance of error. That kind of granular control is essential for cost-effective, reliable enterprise deployment.
Okay, now we come to the part that gives us true AI memory. And it's arguably the biggest game changer for complex workflows. The 1 million token context window. This is a staggering figure, especially when we compare it to the standard context windows of even the recent past. Let's really detail the scale and scope of this capacity for everyone listening.
This is a profound leap. 1 million tokens, that equates to roughly 700,000 words. To help you visualize that scale, we're talking about 1,500 pages of single-space text.
1,500 pages.
Or, if you're a developer, it's about 30,000 lines of code. It's the equivalent of putting about 8 average-length English novels into the model's immediate working memory all at once. And having the AI be able to fluidly reference any sentence from any of those 8 books instantaneously.
Wow. That's a profound shift. Because it means the model is no longer just processing a snippet of a conversation. It has the entire code base or the entire handbook or the entire legal history right there, ready to reference without needing to go search an external database.
Exactly. This shifts the model's fundamental function from being a stateless query processor, which, forgets everything after the prompt is done, to a highly functional, stateful reasoning engine. And its strategic utility in enterprise settings is monumental.
Tell me more about that.
Well, think about enterprise users. They can upload an entire company-wide compliance manual, all project documentation for a decade, or a massive set of legal contracts. And all of it resides in the model's immediate working memory for this comprehensive cross-document analysis. The model can synthesize competing clauses from documents written years apart, a task that would take a human paralegal days to complete.
You touched on something vital there. The reliance on retrieval augmented generation, or R. For those who aren't familiar, RI is what most companies use right now to inject external knowledge into smaller LLMs. You retrieve relevant text snippets and you basically paste them into the prompt. And that process can be clunky and often fails to find the right needle in the haystack. So how does a 1 million token window change that reliance?
It drastically reduces the reliance on those complex and often quite brittle RI pipelines. If you have a 100,000-page document, RI has to break it into tiny chunks, index it, and then hope the user's query is precise enough to retrieve the exact correct chunk.
And if it's not?
If the chunk it retrieves is 90% correct, but it misses one crucial sentence 500 pages later, the answer is flawed. With a 1 million token context window, the model can perform retrieval and synthesis across that vast data set in a single holistic pass. The sources show Gemini 3 maintains high accuracy even at 128K tokens and dramatically outperforms previous models at the full 1M token mark on those famous needle in a haystack tasks. The problem isn't just solved. For large single-source documents, it's practically eliminated.
But dealing with that much data sounds enormously expensive, especially if I have to re-upload and reprocess those 1,500 pages of legal text every time I ask a follow-up question. Did the research team find any solutions that Google implemented to make this massive capacity economically viable for repeat use?
They did, and this shows a very smart business strategy that's clearly aimed at driving enterprise adoption. Google has implemented advanced context caching mechanisms. So if a developer uploads a massive static document, let's say that 1,000-page policy handbook, and queries it repeatedly over several hours or days, they pay a significantly reduced rate for those subsequent queries because the base context is temporarily cached on the server.
That changes the whole economic model?
It completely does. It lowers the operational cost for continuous analysis, and it actively encourages you to use Gemini 3 as that stateful knowledge management system. A system where your critical enterprise knowledge is always loaded, always ready for analysis, and always in the AI's immediate working memory.
So it transforms the model from a service you ping occasionally into a permanent, highly intelligent digital repository for your most valuable data. Okay, so architecture is fascinating, but performance is what really validates the investment. In Section 2, we're going to break down the benchmark scores that really substantiate Gemini 3's claim to state-of-the-art performance. And as you said, these are not just vanity metrics. They translate directly into reliability for complex agentic workflows.
That's right. If the architecture is the foundation, then the benchmarks are the engineering certificate. What's critical here is that the scores are corroborated across multiple independent analyses, which suggests Gemini 3 has definitively established a new state-of-the-art, or SOTA, across key areas of abstract reasoning and reliable action.
Let's start at the very top tier of intelligence testing, academic reasoning. Humanities Last Exam, or HLE, is designed to be notoriously difficult. It tests knowledge and reasoning way beyond the scope of a high school degree. What did the research team find regarding Gemini 3's performance here?
The HLE benchmark tests complex, really PhD-level reasoning and general expertise across diverse academic fields. Gemini 3 Pro achieved a 37.5% score without access to external tools or search.
Without tools.
Which signifies a massive lead over publicly known competitor scores at the time of publication. And the enhanced, less constrained DeepThink variant is projected to achieve over 40%.
And that percentage isn't just a number, is it?
Not at all. It represents a profound increase in the intrinsic reasoning capacity, which is crucial for handling novel and highly abstract concepts. It means when the model is faced with a problem it has never seen before, which is common in scientific R&D or advanced enterprise strategy, it has the raw cognitive firepower to piece together a solution.
And how does that translate to scientific accuracy?
Well, when you combine that HLE score with the GPQA Diamond score of 91.9%, you have quantifiable proof of superior scientific knowledge and accuracy on these advanced multi-step questions that require deep domain expertise. It confirms the model isn't just generalizing, it's retaining and manipulating highly specialized knowledge with high fidelity.
Let's talk about a benchmark that specifically targets qualitative intelligence, abstract visual reasoning, or ARC-AGI-2. This test is designed to be tough for LLMs because it requires nonverbal, pattern-based problem solving, like figuring out the rule that transforms a small visual grid into a larger one.
Here, the leap is arguably the most impressive qualitative indicator of improved intelligence. Gemini 3 Pro scored 31.1% on ARC-AGI-2. Now, to put that into perspective, based on the analyses we reviewed, this score is nearly double the performance of the leading competitor. It's a huge structural jump from previous Gemini models.
Why is this benchmark so revealing? And why does the MOE architecture help here?
It's revealing because it tests fluid intelligence, not just memorized knowledge. It forces the model to derive a new, unseen rule from a very limited set of examples.
So it can't just look up the answer.
Exactly. Older, dense LLMs often struggle because their training is inherently geared toward language statistics. They look for patterns in text, not abstract logic in visual space. The 31.1% score indicates a core, qualitative improvement in handling these abstract visual puzzles and novel, unfamiliar challenges, the kind of out-of-the-box thinking necessary for true, flexible agentic planning.
And the MOE.
The MOE helps by routing the visual data to specialized geometric or pattern recognition experts that can focus purely on the structure, not the linguistic label.
Now let's turn to the hard skills needed for reliability in the workplace. Math and code. The model's mathematical intuition is often gauged by how well it performs on competition-style math problems, which require sustained, error-free logic.
And we see clear dominance in the quantitative domain. On the AME 2025 benchmark, which is advanced high school math requiring multi-step problem solving, Gemini 3 Pro got a perfect 100% score with external code execution.
Okay, so that's parity with rivals.
It is, but the research highlighted a key differentiating factor, the performance without tools. That was a remarkable 95.0% score.
I want to spend some time on this. Why is that no tool score so fundamentally revealing of the agent's reliability?
That 95% no tool score is crucial because it demonstrates robust innate mathematical intuition. See, when an AI solves a complex math problem, it can either reason it out internally using its model weights, or it can generate Python code like x equals 5 plus 3, and then execute that code externally to get the answer.
Right, it can phone a friend.
Exactly. Older models often had to use external code execution for even relatively simple arithmetic checks because their internal reasoning was leaky. And if an agent has to constantly depend on an external environment just to verify every calculation, that introduces latency, complexity, and points of failure. The high 95% score proves that the Gemini 3 Pro's internal reasoning engine is powerful enough to solve these complex problems directly. It drastically reduces its dependency on external environments just to do basic logic checks.
So in a real-world multi-step task, say calculating resource allocation across 4 different cloud regions, the agent is far less likely to fail on a simple arithmetic error in the middle of a complex operation.
That's it, exactly. This robustness translates directly to greater confidence and fewer failures when you're executing these multi-step agentic workflows. And when reliability is paramount, which it is for enterprise automation, you want the AI to be intrinsically smart, not just a highly efficient orchestrator of external tools.
And for software developers, coding performance is paramount. How does Gemini 3 stack up for real-world software engineering tasks, which often involve reading, messy legacy code?
It performs highly competitively across the board. On the rigorous SWE-bench verified, which tests the ability to fix bugs in real-world open-source repositories, it achieves 76.2%. That's near parity with the best models. That confirms its ability to interpret legacy systems and perform detailed refactoring.
But where does it dominate?
Where it truly dominates is in competitive programming and algorithmic generation. It's scored an ELO of 2,439 on LiveCodeBench Pro. This validates its proficiency for generating functional, efficient solutions quickly. And its top score on WebDev Arena further confirms its proficiency in front-end creation and what Google calls vibe coding, which we can talk more about later.
Here, we've covered intelligence and technical skill, but as you mentioned at the top, the theme of this edition of Tomorrow Unveiled is agency, the capacity for reliable action. So what is the single most indicative metric that validates this structural shift in focus?
Without a doubt, the most indicative metric of practical utility and reliability in the sources is VendingBench 2. We need to unpack this fully because this is the number that separates a smart chatbot from a reliable agent.
The name VendingBench sounds a bit whimsical. What exactly does it simulate?
It is anything but whimsical in its function. VendingBench 2 is a highly sophisticated, long-horizon planning and execution benchmark. It doesn't just test knowledge retrieval, it measures the model's ability to operate in a simulated, resource-constrained environment where it has a limited budget and a series of increasingly complex goals it must achieve over time.
So it's not a one-off task.
No, the tasks involve resource allocation, information synthesis, financial planning, tool usage, and crucially, self-correction when its initial plans fail. It measures long-horizon planning, multi-step task confidence, and consistent tool usage over a simulated period. It assesses if the AI can act reliably over time, which is foundational for building production-ready agents that won't just give up or loop endlessly on step 4 of a 20-step task.
So it's measuring the AI's capacity to act like a CEO with a budget and deadlines.
Yeah.
And what was the score for Gemini 3 Pro on this measure?
Gemini 3 Pro achieved a mean net worth of $5,478.16 on VendingBench 2. And the critical significance of this number, according to the corroborated sources, is that it represents a 272% increase in performance over the leading competitor, GPT 5.1.
A 272% increase. That's not an incremental gain. That is a structural breakthrough that demands scrutiny. How do we corroborate a lead like that outside of an internal testing environment? What structural flaws in its competitors does this expose?
That is the right question to ask. That 272% figure suggests that the model's training, which heavily incorporates reinforcement learning optimized specifically for long-horizon multi-step reasoning, has created a highly robust and significantly less error-prone system for complex action planning.
And what does it expose?
What it likely exposes in competitors is a weakness in persistent working memory and internal self-correction. When an older agent fails on step 3, it often forgets the initial context or fails to interpret the error message correctly, which leads to a complete workflow breakdown. Gemini 3's 1 million token context window and its robust reasoning engine. They appear to solve that persistent memory failure. It allows it to interpret error logs, self-diagnose the mistake, and then retry the test correctly.
So this one metric, more than any academic score, validates the model's focus on being a doer that's ready for these long-running mission-critical enterprise workflows. It suggests Gemini 3 is less prone to catastrophic failure mid-task, which is the single biggest roadblock to enterprise adoption right now. That is a staggering finding. It's truly shifting the goalposts for operational performance. Okay, here's where it gets really interesting. The dedicated research team has shown us the benchmarks, the architecture that makes it possible, and the performance that verifies its reliability. But now let's talk about the products built on that reliability. We're moving from the lab to the factory floor. If you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and consider hitting that new hype button to help us reach more viewers. And of course, be sure to turn on notifications so you never miss an update on the future. So now let's look at how that 272% jump in agentic reliability translates into practical launch-ready tools. Because the launch of Gemini 3 Pro wasn't just about the model, it was about the whole ecosystem built around it. And we are seeing new platforms and tools that leverage its reliability to shift the focus from simple generation to full autonomy.
This is the critical transition from research theory to market reality. Google recognized that raw intelligence alone isn't enough. You need the infrastructure for agents to live and work. And the introduction of Google Anti-Gravity and the Gemini agent really formalizes this new paradigm.
Let's start with anti-gravity. Our research describes this as a platform designed to fundamentally change how software is built, to move beyond the traditional integrated development environment, or IDE.
Anti-gravity is explicitly engineered to move past the autocomplete paradigm, the world pioneered by tools like GitHub Copilot, and toward full autonomy. The system assumes the AI isn't just an assistant suggesting code snippets, but a distinct actor, a high-performing digital coworker capable of planning and executing complex multi-day tasks independently.
Okay, so if the AI is the coworker, what does that make the human developer? How does their job description change?
The human developer becomes the architect or the manager, orchestrating high-level strategic tasks. Anti-gravity facilitates this by shifting the interface from a text editor to more of a mission control. It includes an agent manager view, which acts as a dashboard for high-level oversight.
So what does that look like?
Developers define complex strategic objectives like refactor the authentication module to use the new OAuth 2.0 standard, or generate a comprehensive end-to-end test suite for the billing API. And then the agent just goes to work autonomously breaking that goal down into hundreds of individual steps.
That implies the agents have deep, verifiable access to the actual code environment, not just some sandbox. What kind of critical system tools can these anti-gravity agents actually control?
This is where the reliability that was verified by VendingBench comes into play. The sources confirm anti-gravity agents have deep, real-world tool access that's necessary for full autonomy. They can control the terminal that allows them to install necessary dependencies, run build scripts, and execute tests.
And when a test fails?
Crucially, if a test fails, which they often do, the agent can read the error log, analyze it against the 1 million token context of the entire code base, plan a fix, modify the code, and then retry the loop autonomously. On top of that, they can browse the web SO, researching new libraries, or synthesizing best practices from Stack Overflow to solve problems they encounter, all within that self-correction loop powered by Gemini 3's robust memory.
That sounds incredibly powerful, but also a little terrifying. How does the human developer maintain trust and oversight and control when the agent is working autonomously in the background, possibly making high-stakes changes?
That is the problem that's solved by the concept of artifacts. The agents don't just commit code directly to the main branch. They generate verifiable evidence of their work at every single stage. This includes detailed Markdown implementation plans, proposed architecture diagrams, and critically, browser recordings and screenshots of their actions.
So you can see what it did.
You can see exactly what it did. A developer doesn't have to pull a branch, run the build locally, and manually check the change. They can look at the artifact, the screenshot, or the video recording, and verify the agent's work quickly and visually. The human maintains control and final approval, but the process isn't bottlenecked by manual review of every single line of generated code. It fosters trust through transparency.
Moving beyond the developer environment, Gemini 3 also launched the specialized Gemini agent for general productivity. It's been described as a digital butler that's integrated across the whole Google ecosystem.
Correct, and it's available primarily to paid Ultra subscribers and enterprise customers through Workspace. The Gemini agent is designed to handle complex, multi-step personal and enterprise tasks that require synthesizing information across multiple, often disparate sources like your email, your calendar, and your recent documents.
What are some of the high-value, practical use cases that are enabled by this new level of consistency and that giant context window?
Well, think about the complexity of booking executive travel. Instead of a human doing it, the agent can synthesize flight and hotel availability data, cross-reference it with preferences mentioned in past emails, must be near a gym, prefers a window seat,
Check the calendar availability.
check calendar availability, generate a draft itinerary, and then handle the booking logic. For enterprise use, the value just explodes. It enables automated compliance checks across vast policy documents, ensuring no new contract violates old terms. Or operational diagnostics, where the agent has to analyze error logs, system performance data, and outdated system documentation all at once to identify a root cause. The reliability means you can delegate tasks that previously required 3 different human roles.
And tied back to the coding skill we discussed earlier, the research introduced this delightful term, vibe coding.
Vibe coding perfectly captures the democratizing power of this capability, thanks to the massive coding proficiency we saw in the benchmarks. It's the model's ability to seamlessly bridge the gap between non-technical user intent, the vibe, and functional working code.
So I can just describe what I want.
Exactly. Users can now describe an idea in natural language with high abstraction, like, I need a dashboard that looks retro, uses green screen font, and pulls data from this Google Sheet to track my budget. And Gemini 3 can generate a functional web app in a single shot. This lowers the barrier to entry for software creation, allowing business users to prototype simple tools immediately without needing to wait for scarce engineering resources.
This really shifts the creation of software from being a technical specialty to being more of a generalized description task. That's a profound change. And vibe coding brings us perfectly to the next major component of the Gemini 3 ecosystem, Generative UI. This is perhaps the most visible change for end users. It fundamentally changes how we experience AI results.
Yeah.
It means the answer is no longer a static text file. The answer is a bespoke software application.
This feature is revolutionary because it signals the definitive end of static text output for complex, structured queries. The model doesn't just describe a solution or generate a summary, it builds a tailored, interactive microapplication right there in the response window.
So instead of a static block of markdown text, the model is generating actual code, HTML, CSS, JavaScript, or Flutter to render a fully interactive application directly in the response interface. Let's explore the 2 primary flavors the research team documented.
The first is called visual layout. This leverages the model's native multimodality and aesthetic training to create these visually immersive, aesthetically pleasing, and highly organized responses for complex prompts.
Okay, an example.
For example, if you ask Gemini to plan a 3-day trip to Rome with historical context, you don't just get a bulleted list. You receive an explorable, magazine-style visual itinerary. It's complete with high-resolution photos, maps, and interactive modules that allow for multi-turn customization right there in the interface. It's a highly structured, generated web page that serves as the answer.
That is already transformative. It turns information consumption into a rich visual experience. But the second one, dynamic view, that seems to be the real technical breakthrough that uses that agentic coding capacity.
Absolutely. Dynamic view is the major technical leap. It uses the model's VendingBench validated planning and coding prowess to dynamically design and code a unique, functional user interface perfectly tailored to that single prompt's function. It's generative coding based on inferred functionality.
Can you give us some concrete, real-world examples of dynamic view in action? Something that illustrates that shift from content generation to functional application generation.
Certainly. If you ask the model to help me visualize the cost difference between renting and buying a home over 10 years in San Francisco, it doesn't just output the math or a textual comparison. It generates a fully interactive, functional mortgage calculator. With adjustable sliders for interest rates, property appreciation, and down payment amounts, you can manipulate the variables in real time, and the generated interface recalculates the results instantly.
It builds the tool you need to answer the question.
It builds the tool. Another example that was cited is asking the model to explain the Van Gogh gallery with life context for each piece. Instead of just generating text, it generates a stunning, scrollable, interactive page with a custom font and clickable embedded image analysis tools tailored specifically to the prompt. The model understands the implied need for visualization, interaction, and deep information density, and it builds the perfect tool for the job on the fly.
When the AI can generate a bespoke application in response to a single sentence, it suggests a complete reevaluation of what software is and how we interact with technology.
It fundamentally blurs the line between content and application logic. We are moving toward a future where software isn't a static binary that you download from an app store, install, and then update periodically. Instead, software becomes this fluid, malleable experience generated just in time by the AI.
The iteration speed must be incredible.
Think about it. If you want a dashboard to track project velocity, you describe it, and the AI builds it in 30 seconds. If you realize you need a different color scheme or a new filtering slider, you just tell the AI, and it instantly refactors the application logic and design.
And the research noted that this capability isn't a closed box.
Correct. The release of the GenUI SDK for Flutter further democratizes this, allowing third-party developers to embed these generative UI capabilities into their own applications. An existing e-commerce app, for instance, could generate a custom product comparison table or a virtual showroom interface based on a user-specific, complex product search-all unique to that interaction. The customization this allows is unprecedented, and it hints at the death of the one-size-fits-all software experience.
We've established that Gemini 3 Pro has delivered a quantitative and architectural leap focused on agentic reliability. Now let's place this release in the broader context of the hyper-accelerated AI arms race and address the critical issue of safety. If you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners and continues to allow us to bring you these comprehensive deep dives.
So Gemini 3 Pro has undeniably established a new state-of-the-art, or SOTA, across reasoning, coding, and multimodal tasks. It immediately raises the bar for every competitor. This launch signifies Google effectively countering any previous narrative that they were lagging behind, especially in the practical application of AI to complex tasks.
Our research highlighted that while competitors might maintain a lead in specific niche areas, for example, some people still prefer rivals for highly creative fiction writing or extremely specific text-heavy tasks. Gemini 3's strategic focus is different. What's the key differentiating factor that sets Gemini 3 apart in this competition?
It's operational maturity for delegation. The model's profound dominance in metrics like VendingBench 2 confirms that its strategic focus is on reliability for action. While competitors may excel at pure creative output or raw text generation, Gemini 3 is engineered for predictable, long-running, complex workflows.
So it's the workhorse.
In the competitive landscape, this model is designed to be the trusted workhorse, the agent that won't fail 3 steps into a 15-step enterprise automation task. This verifiable focus on reliability for action is what differentiates it in the highly competitive enterprise adoption battle, where errors are very, very costly.
And as these models become more capable of autonomous action running terminal commands, managing money in a simulated environment, the need for stringent safety evaluations becomes paramount. Our research indicates that Gemini 3 Pro was rigorously evaluated against the Frontier Safety Framework, or FSF.
The Frontier Safety Framework, or FSF, is designed to evaluate models for severe, high-impact risks before they are deployed to the public. It is a mandatory gauntlet of testing. The protocols cover 4 key domains where severe risk is most likely to arise, and these need to be understood clearly.
What are they?
The domains are, first, CBRN. That means evaluating the model's ability to provide information that aids in developing chemical, biological, radiological, and nuclear weapons. Second is cyber offensive capabilities, checking if the model can autonomously plan and execute sophisticated cyber attacks. Third, harmful manipulation, assessing its ability to generate highly persuasive, deceptive content at scale. And finally, machine learning R&D risks, specifically looking for the potential for misuse or dangerous acceleration of autonomous AI development.
That sounds like a comprehensive and very necessary hurdle. What were the findings regarding Gemini 3 Pro's performance against these risks? Did the new reasoning capabilities push it closer to a dangerous threshold?
The most critical corroborating detail from all the safety reports is that despite the massive increase in reasoning power and agency, Gemini 3 Pro was found not to reach critical capability levels, or CCLs, in any of the severe risk domains.
So it passed.
It passed. While the model shows improved reasoning and can solve nearly all of the hard cyber challenges, it does not yet possess the ability to independently design biological weapons or execute sophisticated high-impact cyber attacks without substantial, specialized human direction. It remains a powerful tool, not an autonomous, malevolent force.
And there was a specific mention of training related to reducing sycophancy. That sounds like an ethical alignment detail, but it's actually a factor in reliability too.
That's right. The model's alignment training was specifically focused on mitigating a common problem in foundation models: sycophancy. This is the model's tendency to just agree with the user or flatter the user even when the user is factually incorrect.
A yes-man AI.
Exactly. The training included specific reinforcement learning from human feedback, RLHF, to reduce this tendency. This tuning ensures the model prioritizes factual accuracy and correction over simply affirming the user's input. And this is a key trait for enterprise reliability, where a yes-man AI could lead to very costly errors in high-stakes environments.
Lastly, let's talk about where users and developers can actually access this new power. Where is Gemini 3 Pro being deployed, and what's the fine print on accessing these powerful new features?
The deployment is broad and immediate across the entire Google ecosystem. Gemini 3 Pro is integrated into Google Search in AI mode, the main Gemini app, and it's accessible to developers through Vertex AI, Android Studio, and the Gemini command line interface. Its immediate reach is vast, hitting all major user touchpoints.
But the research noted a key caveat regarding accessibility, especially for the individual user who might be trying out the free tier.
Yes, this is a critical commercial detail. While Gemini 3 is available in a free tier, free users have reported severe rate limits, sometimes hitting throttling after just 10 or 15 prompts. This indicates a clear segmentation. The full power, including the 1 million context window, the robust deep think reasoning, and the reliable agentic capabilities, are largely reserved for paid Ultra subscribers and, most importantly, high-volume enterprise users accessing it through Vertex AI.
So the most resource-intensive cognitive capabilities are clearly monetized.
They are. Which makes sense. The cost of running that sparse MOE architecture at full capacity for 1 million tokens is obviously substantial, and they are prioritizing paying customers for those high-reliability workflows.
What a profound release. Let's quickly synthesize the themes we've explored on this edition of Tomorrow Unveiled. Gemini 3 Pro signals a definitive end to the smart chatbot era. Its architecture, that sparse MOE running on custom TPUs, gives it unparalleled efficiency and scale. And its 1 million token context window grants it the memory it needs to process entire code bases and legal documents reliably, eliminating the biggest flaws in previous RD systems.
And critically, the benchmarks prove this reliability. That 272% lead in agentic performance, validated by VendingBench 2, that's the number that translates theory into operational reality. This model is engineered not just for knowledge, but for consistent, multi-step action. It really is the workhorse AI we've been waiting for.
And the synchronization of these breakthroughs with the new ecosystem platforms, that's the strategic genius here. Anti-gravity positions the developer as an orchestrator, while generative UI turns natural language input into functional, interactive, bespoke software applications in real time. This is about building the future of software, not just the future of text.
And this is the final provocative thought we want to leave you with. The synchronized launch of the generative UI and anti-gravity platforms suggests a strategic goal to transform natural language into functional software interfaces. The technical capacity of Gemini 3 means that the boundary between static content and application logic is dissolving. The next frontier isn't just better text or better images, it's instant, personalized software generated on demand, challenging the entire paradigm of how we define and build digital tools.
Thank you for joining us on this deep dive into Tomorrow Unveiled. We love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about Gemini 3 Pro and the agent-first future it represents. If you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and consider hitting that new hype button to help us reach more viewers. And of course, be sure to turn on notifications so you never miss an update on the future. And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It truly helps us reach new listeners. We'll see you next time as we continue to unpack the breakthroughs that matter.